All right, ladies and gentlemen, I'm going to introduce you to section 4.3, and we will be going through this video of me teaching from last year. It's going to look a little weird because I'm going to basically be talking to myself, and we'll just find out how I do. If I need to pause the video at any time and edit it to change things and make things better, I will do so because I want it to be the best it can possibly be. So here we go. Let's see what I said last year.
How long did it take you to figure that out?
I mean, she told me so.
Oh, okay. Come on, Staley. Let's start this thing.
Okay, so some of these things we've already talked about, things like the standard position of an angle.
Yeah, we have.
Initial side, terminal side. What do you think we mean by initial side?
Starting side.
The starting side.
Amen.
And what do you think we mean by terminal side? The ending or stopping point.
Right.
Okay?
Terminal.
That's as complicated as those terms get.
Yep.
Typically, we have an initial angle that starts at 0.
Amen.
So our initial side is, and then we rotate in a counterclockwise fashion. That's a positive rotation. A clockwise fashion is a negative rotation. So when I'm at the top, I'm at 90 degrees. When I'm on the far left, I'm at what?
180.
180.
Amen.
When I'm at the bottom, what am I at?
Well,
270.
Yes.
If I make a complete revolution, I'm at 360.
Cool.
So
what? Okay, you got an angle. All right, it's in quadrant
that's
2.
a 135 degree angle.
Yes, yeah, I hope it is. Looks kind of like 135. 45 past 90, yeah, okay. That
Can you
makes
tell
sense.
me what we would call the green one?
Well, it
You have a
has
few
to be.
minutes to talk to your, or I should say minutes, seconds to talk with your neighbors. And see if you can come up with the green one,
Okay.
seeing that the red one is 135 degrees.
Well, I'd say
All right, so what's the green one?
it's got to be past negative 180.
Negative 225 degrees.
Yeah, that makes sense because you're going 45 past.
Okay.
Right. Past negative 180.
Those are called coterminal angles.
Coterminal.
Coterminal.
Gonna write that word.
Why do you think they call them coterminal?
Because they both terminate at the same side.
Not necessarily because they go together to make 360, although these two do. That's true. 360. That's true. These two do. I mean, if you took the absolute value of one and added it to the other one, you would get 360. So that's true in this case.
Yep.
What do you think coterminal means? They have to end at the same place.
Hold on a second. What do I got? Survey results? What is that in my video? I'll have to find out what that's about and then get back with you. Okay, I figured it out.
End at the same place. Does that make sense?
They start in...
So I'm going to ask you another one.
Ooh. The purple.
What's the purple one?
Okay, looks like we're going past 360. Looks like we're going 135 degrees past
What's the purple
360.
one? Okay, you got a few seconds to talk to your neighbors and figure out what the purple one is. All
Yeah.
right, what's the purple one?
Wow, that wasn't a whole lot
What's
of
the
seconds
purple one?
right there.
495. That's true. It is 495. Now, how did we get to 495?
135 past
We
360.
added 360.
Right, yeah.
And then another 135.
Nice.
That's how we got there. 360 plus another 135.
That makes
That's how
sense.
we ended up getting this one. Mr. Heinrich had a good point. He said, does coterminal mean they start and stop at the same point? That's true. That's true. They start
job,
and
kid.
stop at
Good
the same
job.
point. So that was a good point. I assumed they would start at the same point. I should have stated that. All right. This stuff you've already looked at.
Yeah, that's
Standard
boring.
position angle starts at 0. And, we follow both Didn't mean to write on that. Let's get rid of that.
Yeah.
So 30-degree angle here.
This might get really boring, folks, so I might skip ahead a little bit because
So a 30-degree angle, that's like right there.
Yep.
So I need a positive coterminal angle.
And let's go with the smallest
And
positive
I need
here.
a
Smallest positive. Because we could have a
negative
million of these
coterminal
things if we went with as many as we wanted to.
positive and a negative. Okay,
Yep.
so the positive one would look like this,
Okay. Smallest positive.
and the negative one would look like that.
Okay.
So positive and negative.
So 30 degrees past 360, that would be...
Okay, so how about that negative one?
Oh, you want to go negative first. Whoa.
Negative 330 degrees. You're stopping 30 degrees shy of a full revolution.
Yep.
Okay? What about the positive one? Stopping 30 degrees shy of a full revolution. Okay?
Now, by full revolution, are we talking about the kind where you overthrow the countries? I'm just curious.
What about the positive one? That's 390 degrees. Okay, a full revolution plus another 30 degrees.
Man, there's lots of people.
Okay, so let's do the same thing over here with the next one.
Negative 150. Okay.
Negative 150, that's about right there.
Okay.
So, a positive and a negative.
Can we speed this video up? I wonder if we can.
Anybody got either one of those?
I'm gonna try this. See if I can get this to speed up a little fast. I don't think so. I can't figure it out at the moment. Well, come on, play. I said play. Hello? Is he in
Positive.
there? Okay,
Let's
there he
see.
is. Whew.
Positive
lost
would be
him.
going from here to here.
Right.
What'd you say it was? 210 degrees. Do you agree with that or disagree?
Was he talking to me?
You should agree. That is 210 degrees.
Yep.
Stick to your guns, man. Just be patient. You gotta make sure. Gotta make sure everybody knows what's going on. Okay, so negative
that
would
sounds
have
weird.
to follow the negative rotation, go past it, and then come back to it.
Okay.
That's negative what? Negative 510 degrees.
Okay, so it's a full negative 360.
Negative 510, that's right, because it's a full negative 360.
And
then
then,
negative 150 on top
yeah.
of that.
Yep, that makes sense.
The next one's a little bit more tricky because you guys are barely getting your feet wet in radians.
It's true. It's true. You guys are learning.
So, may I remind you, this is 0 and this is pi.
Okay.
What's at the top of the circle? What would be at the top? Pi over 2. If you're at a party, you want to say pi over 2.
Right. Don't say half pi.
That would make this 2 pi over 2,
Yeah?
which would make the bottom one what?
3 pi over 2.
3 pi over 2.
And
And where would you find 4 pi over 2?
back at the beginning.
Back to 0, right?
Amen. I got to get my writing tool available. I don't know what's going on, why it's not available. Share. Okay, minimize that. Get my annotate tool so I can, let's pick a different color. Okay, so he asked me where 2 pi over 3 is. So that would be 2/3 of the top half of the circle. Oops, better put my draw tool on here. I'm going to guess right about there. That's my guess. Let's see if I'm right.
Because that's the same thing as 2 pi. All I'm doing is jumping around the circle in increments of pi over 2, also known on the street as 90 degrees.
Amen.
Now, 2 pi over 3, which quadrant is that in? Just tell me which quadrant you think 2 pi over 3 is.
Quadrant
That's
2.
2/3 of a pi.
Quadrant 2.
Remember, if 1 pi is over here, where do you think 2/3 of a pi is?
It's got to be let.
It's
Ooh,
right there.
Look how close we are. We got pretty close,
2/3
didn't
pi,
we?
right there. I know you're not used to that yet. That's what we'll be practicing this week. Quiz coming Thursday.
Quiz.
We're working hard this week to get this section 3 understood. So, give me the positive and the negative.
Okay, so positive. Oops.
Now, before I release you to try to figure this out on your own, may I ask you a quick question? 2 pi radians, is that the equivalent of 1 revolution around the circle in radians?
Yes.
Yes or no?
Yes.
Is 2 pi equal to 1 trip around the circle?
I already said
Okay.
yes.
Do you understand that that's the same thing as 6 pi over 3? Do you get that? All I'm doing is multiplying the top and bottom by 3 over 3.
Oh.
3 to the top, 3 to the bottom.
That's all you did. Okay, yeah.
Same thing we did kind of in junior high, we just didn't do it with pies.
Right, little middle school math, gotcha.
Okay, now, think about the positive rotation.
Oops. Get my colors different.
And the negative rotation. Okay, the red and the green.
Okay.
See what you can come up with, and I'll give you a few seconds to think about it. All right,
Yes,
let's
sir.
see what we can do with this.
Whoa, man, that is
Let's
way
go
too
with the negative,
fast.
the green one.
Seriously. Okay, the negative one, that's got to be, well, it's got to be past negative 3 pi over 3. It's got to be negative 4 pi over 3. Let's see if we're right.
Now, do you mean negative 4 pi over 3? Yes, you are correct. Negative 4 pi over 3.
Nice, whoever said that.
Okay.
Besides me.
What do 2 pi over that makes a complete revolution if you add those two things together. So that's smart
Absolute
thinking.
value of the one, yeah.
Okay, so how about the red one, the positive? Okay, how'd we get 8 pi over 3?
Oh, because
yeah.
it's a whole 6 pi.
Take a full revolution.
And then add 2 more to that.
And then add 2 pi over 3 to it.
Oh, yeah, that makes a whole lot of sense.
That's how we get that. Good thinking.
Sure.
See, I know you guys are slowly getting used to understanding what radians are.
Yes, math preacher.
I know there's a lot more work to do with that before you will be fluent in radian.
Yes, math preacher.
Right now, you're just taking your baby steps in that new language, but you will get it. I'm confident. Any questions about conversions or finding coterminal angles and what they are?
All right, now, move on.
Okay. Suppose we start with an angle in quadrant 1.
Quadrant
Okay.
1. Okay, that's pretty basic.
And so we've got some angle in quadrant 1 at a coordinate. There's a coordinate in the universe at the point 5, 3.
Okay.
Well, which side of this triangle should we label 5 and which side should we label 3?
Probably 5 for the bottom and 3 for the right side.
What? Flip those? Okay, I would agree with you. To go from here to here is 5 units.
Right, because you
to
go
go
this
from
way
here to here is 3
and then
units.
this way. Oh, yeah. Yeah, that makes
Okay.
sense.
We call this the rectangular coordinate system.
All right, yeah.
Okay, you're very used to it. What does that make for the hypotenuse?
Don't say 4, because it's not a Pythagorean triple.
Right, 25 squared, or 5 squared plus 3 squared is the square root of what?
34.
34. that doesn't simplify. 2 and 17, and neither one of them is a perfect square.
It wouldn't matter if it did.
So we can come up, this is kind of a nice review from what we did last week. Sine, you got to start thinking about your SOHCAHTOA. And then eventually the Choshikow.
Oh, yeah, that's a review of our reciprocal trig functions.
Okay, so sine opposite over hypotenuse. What do you got there? 3 over what?
Radical 34.
3 over radical 34. We rationalize that. What do we get?
We don't need to.
3 radical 34.
That's a
over
good enough
34.
answer right there.
For those of you who need to see that in slow motion, you multiply the top and bottom by the square root of 34.
Now, the idea of rationalizing a denominator is a very old topic. It is not all that necessary. It is, you do have the ability to do that, but we only did it a long time ago because we didn't have cool calculators to divide by really long decimals, and irrational values are long decimals. So we didn't want to divide by, we wanted to divide by integers. That's why we came up, that's why we rationalized. But we've got good technology now. So I'm not going to require you to rationalize denominators. However, you will not see, in a lot of textbooks, you're going to see things rationalized. So you just need to be aware that that's what's going on and not get, freaked out by it. That's all I have to say about that.
Okay, so what about the cosine? Adjacent over hypotenuse. 5 over what?
Adjacent, radical 34.
Radical 34.
Amen.
And once again, we'll get the same kind of result going on. 5 radical 34.
If you have to
over
rationalize,
34.
but not necessary.
And once again, in slow motion, it's that radical 34 top and bottom thing.
Whoa.
It's a terrible looking square root.
Yeah, that's awful.
Okay.
But, we'll forget
What about my tangent? 3 over 5.
Good job. Good
Yeah,
job.
that's easy, right?
Yep.
Opposite over adjacent.
Right.
Now I'm going to circle these two because it would be a whole lot easier, in my opinion, to find the cosecant and the secant if I did.
Yeah, of course.
What do you got for cosecant? Radical 34 over 3.
Man.
I think it's much easier to look at the unsimplified radical, or the non-rationalized version, to get my cosecant. Kind of a waste of time to flip over the other one, then rationalize it again.
Amen. Amen.
That'd be
What a
kinda
waste
dumb.
of time.
Okay, what about my secant?
Come on, radical 34.
Radical 34
5.
over 5.
I bet your cotangents.
And somebody besides that kid over on my left. How about my cotangent? 5 over what?
3.
3. There you go.
Yeah, move on to the next
Flips it
one.
over. What happens if I'm not in quadrant 1?
Not in quadrant 1? What? I didn't even know
Where's
there were
negative
other
5,
quadrants.
3 and then quadrant 2?
Yes, negative 5 3 is in quadrant 2.
Remember how we talked about drawing theta as the closest angle? The reference angle would be to the closest side of the x-axis?
Well, kind of.
Truth of the matter is, you're talking about this angle right here. We can use the reference angle. Maybe I need to use a different letter. Maybe
Yeah.
I should use a different Greek letter
Yeah.
to represent that.
So they don't get.
Try alpha.
There you go, alpha.
So theta would be here.
Amen. Yep.
The
that
reference
makes
angle.
more sense.
A lot of times we use that reference angle, but which side of this triangle should we call negative 5? The what? The bottom, right?
Bottom.
Exactly. This part right here, negative 5. Which side would be 3?
The left side.
The vertical part, right? So What does that make for my
I feel like I'm in, the movie, Remember the Titans, when they're like, strong side. Never mind. Okay.
hypotenuse?
Radical 34. It's the same as the... Why isn't it? Yeah, it's working.
Is it the same as the last one?
Yes, it is.
Yes, it is. So it's the square root of 34.
Yep. Same two side lengths for the legs.
What's the only thing that's going to be different in some of these answers?
Some of them are going to be negative.
Some of them will be negative. Not all of them.
Wow. It's like I'm talking to
But
myself.
some of them, right? Okay.
Preach it, man,
So
preacher.
if we start thinking about sine, right, that's 3 over radical 34. Well, that's going to be your 3 radical 34 over 34. What about your cosine?
Or you could just leave it like that.
Negative 5 over radical 34.
Yeah, that'd be a good answer right
So
there.
that's going to be negative 5 radical 34 over 34. What about your tangent?
Negative 3 over 5.
Opposite over adjacent. 3 over negative 5. Now, does it matter whether I have the negative in the top, the negative in the bottom, or in front of the whole fraction?
Nope.
No, it doesn't matter. I know some of you would ask that, but it does not matter. So I shall pause for station identification so that you can figure out the other 3. You flip those over, I'm sure you did a fine job.
Man, you did a great job. Wow. How in the world?
Okay.
Whoa.
Now.
Man, we should go back and look at that. I don't. First of all, let me pause this. Let me clear out my drawings. Go back here. That was like amazingly fast. But yes, all you're doing is flipping those over. Keep in mind, reciprocals have the exact same sign. We do not change the sign when we talk about reciprocals. We've programmed you in geometry class to think about the slopes of perpendicular lines and how they are opposite reciprocals. But reciprocals in general, or reciprocals at all, don't have a different sign. Remember, to be a reciprocal means that the product of the two numbers has to equal positive 1. The only way that's going to happen is if they're both equal to a positive number or both equal to a negative number. So the sign can't change. It's that whole geometry thing we taught you that kind of throws people off. Okay, back to listening to the math preacher.
Okay. Now.
Ooh, now it's getting good. Starting our unit circle up.
This is a unit circle.
Amen.
The unit circle has a radius of 1.
Let me get this bar out of the way.
So what's this coordinate over here at the outside edge?
1, comma, 0.
What coordinate is that? 1 unit away from the origin. Anybody know what coordinate is 1 unit away from the origin on the right? Isn't it 1, comma, 0?
Yes.
How about the one at the top?
0, comma, 1.
0, 1. How about the one on the left?
Negative 1,
Negative
0.
1, 0. How about the one at the bottom?
0, negative 1.
0, negative 1. See, that's fairly simple, right?
Yeah. Yep, it is.
Every point on this circle has an x value and a y value. Some of them are nice.
Tell them the truth.
There are 16 points that I've highlighted. Now, we know that a circle has an infinite number of points, but I've highlighted 16 of them. Eventually, probably tomorrow, we will be able to go all the way around this circle. Not only will we know their degree measures, their radian measures,
What?
and things like x's and y's and slopes.
What?
Okay, but everything else in between is not so easy. But let's see how we figure out. Let's take a point right here.
Yeah.
And we will call that point x comma y.
X, Y. Ooh, reference triangle.
Which side of that triangle should we call x, and which side should we call y?
Call the bottom
Which
side
side
X.
should we call x? Well, just think about how you go from here.
Yeah, that should be X, and
Up
that
to
should be
here.
Y.
Which side should we call x? Everybody in the room knows the radius is 1, so we all know the hypotenuse.
Amen.
Which side would we call x? And which side would we call y?
Didn't we already go over this with the 5 and the 3?
X would be your horizontal, right?
Oh, yeah.
Y would be your vertical. That's how you get to
good.
that spot.
Good. Yep. We go x right and y
Right.
up.
Does that make sense?
Sure. Sure.
I don't know if that's what you said.
You don't have to tell me twice.
If you did. Oh, yes. Then I would agree with you. Sorry. I misunderstood. Okay. So theta is down here in the corner. What is the cosine of theta? You know, and I know that it's adjacent over hypotenuse. So use what you see in the triangle and tell me what is the adjacent over the hypotenuse.
X over...
X over what?
1.
X over 1. And what do they call that on the street? X.
X. Yep.
Right, because when you divide anything by 1, it's the same thing, right?
True.
I mean, you go up to anybody on the street and you ask them, they will tell you that.
Yep.
I'm not kidding about that,
Nope.
folks.
Nope. Don't.
How about the sine of
You ain't
theta?
kidding about that. Opposite.
Y over what?
1.
1?
Yep. Yep.
Therefore, because I asked you, never mind. Okay, you're right. It is the y value. How about the tangent?
Tangent.
Y over x.
Opposite
When
over adjacent.
in your entire life have you seen y values divided by x values?
Slope.
Slope. This is one of the main things you better learn in this class. Cosine is x, sine is y, tangent is slope.
The math preacher ain't lying on this one, folks. Not at all. If you fail to understand that cosine is x, sine is y, and tangent is slope, it's going to be a very long semester. In fact, I don't think you'll see very good results if you don't get this important idea in trig. A lot of things use it, and you just need to be very familiar with it.
Cosine is x, sine is y, tangent is slope.
You said it already.
Last period asked me if I had any cool ways to remember that. C and S are in alphabetical order, so is x and y.
Okay.
That's all I got, folks.
There we go.
I don't know if you get a tan when you're on a slope. It depends on if the sun is out.
Yeah, which side of the mountain you're on.
If you're actually on a slope.
That's true.
I'm making stuff up here, folks.
If you're not on a slope, you're probably dying.
I know you're rolling your eyes at me.
Yes, you are. We all are. We're rolling our eyes at you. Yes, we are. Here, I'll do it again.
So I'm going to ask you some questions. Let me rewind on what or tell me again, if this is pi, what would be the angle measurement at the top of the circle?
Pi over 2.
Pi over 2. And what would be the angle measurement at the bottom of the circle?
3 pi over 2.
3 pi over 2. Right?
Yep.
We talk about 2 pi over 2. That's the same thing as that over there. Okay, and then 4 pi over 2 is back to the beginning, also known on the street as 2 pi.
2 pi, yes.
Okay. I'm going to ask you questions like this. What is the cosine of pi over 2?
Ooh.
Now, you have to find pi over 2 on the circle.
Okay, that's at the top.
You have to be able to identify whether I'm asking you for an x value or a y value or a slope. What am I asking for?
X.
I'm asking for an x value, right?
Yes.
So, I don't know, you tell me.
X value at the top of the circle
You're
is...
up here at the top of the circle. What's your x value? 0. Ding, ding, ding.
Thank you. Thank you very much.
It isn't any more complicated than that, folks. What about if I asked you for the sine of pi over 2?
Ooh, the y value. How do I do that?
So I find pi over 2 at the top of the circle.
So
I decide whether it's an x value or a y value or a slope.
Y value.
It's a y value, right?
I have to work on my
So what is it? Nice job. Now you'll notice that I call these points the kindergarten points. These are the easy ones. These are on the x and y axis.
Right, they should be the easy ones.
They are 1 unit away from the origin. Your answers to these questions either better be 0, 1, or -1.
Or,
at least for the x's and the y's.
Right. If we get a tangent, it could be something different.
What about the tangent of pi over 2?
Oh, right here. Right here we go.
The tangent of pi over 2. There was a little bit of an argument in my last class over the tangent of pi over 2. So take about 10 seconds and see what you can come up with.
An argument? Who's fighting about that?
Talk to your neighbor.
It's the slope of a vertical line.
It's important to talk to them.
Maybe they don't know the slope of a vertical line. Maybe not. Okay.
So let's see what you got for the tangent of pi over 2.
No slope.
No slope. Or another word for that would be undefined.
Undefined, yep. Okay.
No slope. Some of you were about to say 0.
Oh.
I knew you were going to say 0.
No.
Folks.
No.
The slope of a horizontal line is 0.
Excellent. Excellent. Yes. Whew.
Now I will try to explain to you the difference. Let's ignore sniper fire when we answer this next question.
Ignore it. No snipers.
Do you guys know what cross-country skiing is?
You'll remember from Dora the Explorer, snipers no sniping.
You know what cross-country skiing is? Sort of. Cross-country skiing, you know.
Cross-country skiing?
Like this stuff, get exercise.
Oh, cross-country skiing, where there's... Where
you understand what cross-country skiing is.
Oh, that's
What's
kind of...
the chance of death?
Chance of death is pretty low.
Really? Just doing this.
Cross-country skiing is when you're on a flat
So I got
slope.
0 chance of death.
Zero
Now,
chance of death.
suddenly I'm on a quadruple black diamond hill in the mountains, and I go off a cliff.
Off a cliff.
Okay, I took the wrong turn. Now, what am I doing? I'm falling, right?
Falling, yes.
There is no slope underneath my feet.
No
Chance of
slope.
death,
No slope.
pretty good.
Yep, chance of death pretty good.
There's a difference between 0 slope and no slope.
0 slope
Okay.
and no slope. Yeah, there's a big difference between them.
Try to use the N and the Z to help you remind you if you are struggling with that. 0 slope and no slope.
Amen.
Okay? So that is definitely undefined on this. Okay? I don't think we'll go too much farther with this. Some of these things, although we could answer this one. -270. Okay, -270. Where is -270 on the circle?
Ooh, that's back at the top again, isn't it?
Keep in mind it's a negative rotation, so we're going this way.
Right.
It's
gonna
on the
be back
positive
up
side
here,
where?
isn't it?
It's the same place we've been dealing with the last several questions.
Yes.
So, did they ask me for an x value or a y value or a slope?
Y value. Y value.
Come on, sign. Is it x value, y value, or slope?
I said
It's a
Y
y
value. Can
So
he
what
not
is it?
hear me? This is ridiculous. He's not listening.
It's 1. Thank you very much.
Yes.
Okay,
the Y
stay with
value
me.
is
Don't
1.
Don't lose sight of the end here. 3 pi. Where's 3 pi? Here's 1 pi, right?
1 pi.
2 pi.
2 pi.
3 pi.
3 pi.
What is the slope of this line? 1.
1.
Said 1.
Who said that?
0.
0. We talked about that
Okay.
already.
Now secant goes with what?
Cosine.
Secant goes with which trig function?
Cosine.
Cosine.
Yes.
So I know it's got to be dealing with cosine. Where is 11 pi over 2? Let me get rid of some of this. See if I can get us a decent looking shape here. 11 pi over 2. Oh, man. I have to pick this up tomorrow.
Nope, we're going to finish it, man. Nope.
You can go into the page 4.
Wait a second. What are you doing?
The file that
We
says
aren't
worksheet.
doing this. Where's my last video? Give me my last video. All right, we're going to finish this question. So cosine 11 pi over 2 is what we're interested in. Now, where in the world is 11 pi over 2 on this circle? Well, if 1 pi over 2 is right here at the top, and 2 pi over 2 is over here, then we got 3 pi over 2, 4 pi over 2, 5, oops, went right past it. What in the world am I thinking? 5, 6, 7, 8, 9, 10, 11, 12, 13. Ooh, I went past it, didn't I? Man, I was having a lot of fun there. 13, 12. Oh, I'm down there at the bottom, aren't I? Right? So, on the unit circle, we're sitting down here at the bottom. Basically, you have 8 pi over 2 would land me over on the right side. 9 would be at the top, 10 on the left, 11 would be at the bottom. You're just counting around in increments of pi over 2. So we land down here at the bottom. We know that's the point 0, negative 1. And what is the cosine of that? Cosine is the x value, so we're dealing with 0. So this part is 0. Now, what is the secant? Secant is the reciprocal. So remember, anything can be divided by 1. So the cosine is 0 over 1, and that would mean the secant is 1 over 0. And what do we know about 1 over 0? Undefined. It doesn't exist, folks. Okay? So that's the answer to that question. Thank you for listening to my entire video of me talking to myself. Have a good evening. Bye. We'll talk more about this stuff in class. If I can figure out how to shut this thing off.